So I'm Rohan. I'm a PM on the Android launcher side.
And I'm Chris Baines, and I'm an engineer on the Android Developer Relations team.
A lot of this talk will be kind of similar to our I/O talk, but there's a lot more detail around common scenarios and new restrictions that we've added on this subject, so I do want to make sure we cover all of that in the talk today. So quick recap before we get started. I think a lot of you folks will probably have played with GestureNav on beta by now, but here's what it looks like. It is a swipe up from the bottom to go home. Swiping up and holding from the bottom gets you to your recent apps or overview. And finally, back is a swipe horizontally from the left and right edge. I think the image doesn't show the right edge, but I'm sure folks haven't played with, or have already got a chance to play with it. If you haven't, make sure you do, especially for app developers here. I think it really helps to actually see this with your app and try to get an idea for what conflicts might be. But we'll walk through a lot of the potential cases here. Great. So this question continues to get a lot of attention, so I figured it might be a good time to actually talk about which nav Android will use moving forward. It's very similar to what I said before too, but 3-button mode is going to continue to be required across devices in Android. There's a pretty core accessibility use case or need, and frankly, some people just don't like gestures. We know that's true, especially the diehard Android fans like me. Always happens, but 3-button mode will continue to be required. Now, GestureNav is joining the list as an optional mode. So if a device maker wants, they can bring GestureNav as an out-of-box experience and put it on their phones. One of the common questions that we saw from I/O and we've received from other developers is, what about all these other models like Samsung's, Huawei's? What happens with those? So there is kind of a tension between fragmentation for devs and user experience. So from our perspective, we do want to make sure that users don't face a lot of churn, but at the same time, we want to limit how fragmented the ecosystem gets. So basically, any device maker that wants gestures will have to prioritize our platform GestureNav and offer it on their device. And any alternate opt-in navigation mode, like swipe up from the bottom for every action, will have to get put one level deeper within settings or under advanced or something like that. And it can't be promoted or it can't be pushed onto new users. So it's more of like a legacy support thing that we're okay with device makers doing. Right, so one more time, why is this so important from your perspective? A lot of our users, a lot of the big trends right now are that users desire this immersive experience, and that's partially why we moved to make GestureNav a unified solution in the platform. So desirability is a huge thing, and for a lot of apps, making sure that you fill that need or fill that desire, it'll help gain an edge in the ecosystem right now. And the second part is kind of the more obvious part, but obviously with GestureNav, we are taking part of your edge away. So we want to make sure that your app works in that new mode or in any sort of gesture mode with optimal user experience. Cool. So we'll dive into what it takes to make your app nav ready. You'll notice I keep saying nav ready, or I'm referring to it as nav ready. It's because it's not just GestureNav. There's a lot of these things that kind of apply across navigation modes. So I think the 3 things here that we'll talk about are making your app go edge to edge, which Chris will explain. The second one is leveraging insets, which is existing window insets and gesture insets to better place your content in your app. And the third and final one is overriding system gestures. There are some updates here, and there's some more clarity that we'll be providing in today's talk, but those will be kind of the 3 main things. So I'll hand it off here.
Thanks, Rohan. So we've kind of coined this term called edge to edge, which is something we've kind of made up over the past 6 months or so. So what do we actually mean by that? Well, simply, this is what your typical app looks like on Q today. So if you create an app with a template in Android Studio, you'll get something like this. And your app, in terms of bounds, will be below the status bar and above the navigation bar. So on Q, what we really want is for this, so the navigation bar to disappear. And what this allows is that your app to bleed into well, more of the screen, the bottom of the screen in this instance, which is great for the user, because users are paying money for these like big displays, and we want your apps to make the full use of them. And then when the user scrolls, you'll get this. So the content will scroll behind that navigation bar, the pill, as we call it. So in terms of kind of a recommendation, drawing behind the navigation bar is now strongly recommended to the point of being, you should definitely do this. But before Q, it's kind of optional. But one thing you'll see as we go through kind of the APIs later is that the work you have to put in and the APIs you're going to use are available since like API 21. And so actually, the work you're going to put in is applicable also to before Q as well. And so to make it work before Q, you're doing the same thing. And then similarly for the top of the device, the status bar, we want the same thing. So you'll go from this, and then we want apps to be drawn behind the status bar. Again, creating a more immersive experience. And again, when the user scrolls, your content will scroll behind the status bar and create, immersive experience, something we'll keep saying again and again in this presentation. In terms of recommendation, it's recommended on Q, but not quite as strongly as the navigation bar. And this is because it's not applicable for all content types. So if you have kind of an image, which is kind of sitting at the top, like a collapsing toolbar layout or similar, it usually makes sense. But if you've just got like a list of items, it doesn't always make sense. You can still do it. So the Gmail app has recently updated, and they have a kind of like very, very slightly translucent status bar, even though it's just a list of conversations. So you still can do it, and it still does make sense, but it's up to you. And so what we mean by going edge to edge is that your app will go from this and then start drawing edge to edge. So that's talking about what it is, and let's talk about how you actually do it. So the first thing to know is that the system will help you as much as possible. So on Q and onwards, the system is responsible for protecting the system bar buttons. So in gesture nav, that's the pill at the bottom. If you're using a button mode, it's either 2 or 3 buttons. So if we dig in here, you'll see that the system bar changes color based on the content behind it. And maintaining contrast, the user can still actually see the system bar. And so protection can be in the form of dynamic color adaptation, which you've just seen, but it can also be in the form of a scrim, a translucent scrim, which you can see here. One thing to know here is that the system will only draw that scrim for you if your target SDK is 29 or above. And the system will choose when to switch between color adaptation and the scrim based on varying things. Button mode will nearly always use a scrim. But OEMs can also choose to prefer a scrim over the color adaptation if their device isn't quite fast enough. So going immersive, which is something we've coined a few things, there's 3 kind of main tasks you need to do. The first is you need to change the system bar colors. The second is to request to be laid out full screen, so your app is actually being displayed behind the system bars. And the third is to avoid any overlaps with the system UI. So the first one is to change the system bar colors. So as we said earlier, it's kind of strongly recommended on Q, so we'll have a values v29 variant theme, and we're just going to change our navigation bar color to be transparent. And at that point, we get something like this on the right-hand side. Now, as I said earlier, it's kind of optional before Q, but we'll still mention it. So this time in our values folder, so our base kind of themes, you should really be sort of providing that scrim yourself. So one way you can do it is by setting a translucent white color as your navigation bar color. If you're in a light theme, and if you're in a dark theme, do a translucent black instead, and you'll get the same kind of effect. So we just mentioned themes there. Now, Nick and I actually have a talk tomorrow where we go through themes and styles in a lot more depth. What we've just shown you into the code isn't the greatest, but we go more into what you should actually do in themes and styles, how you organize it, and hopefully some of the tips and tricks you can learn. So yeah, come and join us tomorrow if you want to learn more. So back to actually edge to edge. The second thing you need to do is to request to be laid out full screen. And we're going to use the set system UI visibility method. It's a flag-based API which has many, many flags. We only care about 3. The first 2 are called flag layout hide navigation. And what that does is that it tells the system to lay out your app as if the navigation bar wasn't there. So basically, it will lay out your app as if behind the navigation bar, basically. And the second one is layout stable. And what that tells the system to do, it's kind of a meta flag, but it tells the system to lay us out at our most extreme, so basically edge to edge. Optionally, if you want to also be displayed behind the status bar, you can use the layout full screen flag. Now, none of these are named particularly great, but all the docs kind of go for use cases, so they're pretty good. Once we've done that, and it's requested to be laid out full screen, that brings us onto the topic of insets. Now, you've probably heard this before, but what does it actually mean? Well, insets, at the most simple, are a collection of values which tell you how much to move views in by. And it allows us to do things like move us out of the way from the system UI, not conflict with any gestures, stuff like that. Now, which content to move on the screen, so which views, depends on the type of inset you care about, and also its purpose, and we'll go through that now. So the first type of inset is called system window inset, and they tell you where the system UI is going to be displayed above your app. They are commonly used to move views which are clickable, and so they're not obscured by your system bars. So here you can see a fab, and typically you'd set a margin on it about 16 dips. Now here, when we're in gesture nav mode, the fab is actually partially obscured at the bottom. Now it's not such a big problem on gesture nav, but really what we want to do is push that fab up so it's above kind of the gesture zone. On button mode, it's actually more of a problem because it's a bigger navigation bar, and so we don't want that fab to be obscured by the navigation bar, so again, we want to move it up. And so this is by using the system window insets, and tells you the size of the navigation bar, therefore we can just move it all up. The next type of inset is called system gesture insets, and these are new in queue. And these represent the areas of the window where the system gestures, so that left and the bottom, are going to take precedence over your app's motion events. Visually, they look a bit like this, and include both the vertical edge for the back gesture, and also the bottom edge for the home gesture. So the user can drag to go home. And the third and final type we're going to talk about today is called mandatory system gesture insets. Great name. Now, they're a subset of system gesture insets. You wouldn't typically use these, but it's good to know what they're about. Now, and they define the areas, the system gesture areas, which can't be overridden. So Rohan's going to talk in a bit about how apps can override the gesture zones. Now, these insets tell you the ones that you can't use with that API. And currently, that is only used on the home gesture zone, and that is because we don't want apps to ever users to ever feel trapped in apps, and we want users to always be able to swipe home and exit your app. So as a quick summary, system window insets are for clickable views. System gesture insets are for draggable views, so things like bomb sheets. And then mandatory system gesture insets are just for checking the exclusion APIs. So that's kind of a summary of what insets kind of are. And now let's look at how you actually use them and the APIs that you're going to use day to day. And that is the infamous window insets class. So you've probably seen an example like this, which is the onApply window insets listener method. And so you'd set this on a view, and then at some point later, because it's async, you'll get some insets given to the listener, and then you do something with it. Now, one tip for this is that it was added in API 20, and so it's on view. But really, you always really want to use the view compact class, regardless of your min SDK. And that is because we're continually updating this implementation throughout the API levels. And so this API, the window insets API, has changed quite a lot since it was first introduced, which we'll go through in a minute. But the view compact instance has all of the new APIs, which are much nicer to use. So in terms of the APIs, window insets compact, which is the instance you'll get, has 4 main APIs. Get system window insets, system gesture insets, and mandatory system gesture insets. The fourth one called get stable insets, we're not going to talk about in this presentation, but it's there if you want to go and read the docs. Each of those methods returns an insets instance. And very simply, it's pretty much this. It's not actually this, it's not a Kotlin class, but it's pretty much the same. It's just a Java pojo with a left, top, right, and a bottom. It's just an int. So it tells you how many pixels your view should be inset for that particular type. So let's go through a very simple example where we're going to take this app, which is just kind of one of the templates from Android Studio, and we're going to make it edge to edge. So first thing we're going to do is change our navigation bar color. So we'll change that to transparent, and then before we get this. Then we're going to request our app to be laid out full screen. So we're going to use the set system UI visibility method with our flags. And after that, we'll get this. So obviously that's not great at the moment because the text is far too close to that navigation bar, and so the user can't actually read it really. So what we want to do is add some padding. So we want to actually move that navigation bar up a little bit, and so you can actually see it. And so we're going to use the onApplyWindowInsets method on that bottom nav, and then we're going to update padding. So here, because that bottom navigation view is a clickable view, we need to use the system window insets. And so once we've done that, we'll get some insets, and then we'll get the bottom from the system window insets, and then just update the padding based on that. Well, using that. And then once we've done that, we'll go from this, and then to this, which is kind of the visual effects we actually want here. And that's just one example where you can use padding to update views, but you can do any kind of layout you want. So if you want to instead use margin to just push something up, you can do that as well. It's totally up to you, but the visual effects of padding is usually what you want. But you might instead want to use like, margin here, and then put another view behind, or whatever it is. But it's just to show you that you can do either. And then you'll get something like this instead. So if we go through a slightly more complicated example, so this is kind of similar to what Google Photos has, when you kind of open a photo and you'll get the button bar at the bottom. And the way this is implemented is quite simply via a linear layout. So if we change the background to purple so you can actually see the bounds of it, and then have a look at what the view's like. So it's just four image views I think I implemented with. But the important thing to know here is that the linear layout itself has some padding around it. It has 32 dips of padding exactly, which is going to be important later. So after applying all those things we talked about earlier, so set system UI visibility, changing the navigation bar color, blah, 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 we get something like this, which doesn't quite look right. You can see that the padding at the bottom of the view has kind of just disappeared, and it's now very tight to the navigation bar. And the reason for that is because we're using update padding, or set padding. And so what we're doing is, even though we've set 32 dips of padding in the layout, our onApplyWindowInsets method listener is just completely wiping it out, and then we're just setting it to whatever the system window insets is. So one way you can fix this is using this. So we'd grab the kind of original padding out of, so say in your onView created or onCreate, whatever it is. And so we'd keep that value, which is 32 dips in this instance, and then in our actual window insets listener, we just add them together. And that does work, and that works great. But the problem is you're going to be doing this for every single view you ever create. So it obviously isn't great and isn't very maintainable. But it does give you effect. And so this is what it would be like after that, which is kind of what we want. So this is an example of something you could do to generalize it. Now, I know there's a lot of code on screen, but this is kind of a general solution to what we just spoke about. So what we do is we create a kind of a rect, a data class which keeps our left, right, and bottom of our original paddings. And that record initial padding for view is just a function which kind of grabs it from the view. And then we could create an extension function on view called doOnApplyWindowInsets. And what that does, when you call that, it will kind of create that snapshot of the padding. And then we just pass through in proxy to an onApplyWindowInsets listener, and then pass it through to a Lambda. Now, I'm not going to expect you to remember this, but the important thing to see is that the way you use this then becomes a little bit like this. So we no longer have to sort of store that padding outside the Lambda so you can reference it. It's passed through to you as a parameter, and then you can just always grab it. It's always going to be the correct value. Now this was spurred on by something that Nick sent me, which was window insets are too damn hard. And it's true, the API is not the easiest to use. It comes from a time where window insets were very reactive, whereas now they're pretty static. You want to request something at the start of your kind of life cycle, and then it's always the same. And so we're stuck with this API now, but we can make it nicer to use. And one way you can do that is via data binding. So wouldn't it be nice if we could just move all of this code to layouts? Where we keep our views are in XML files, so why isn't this stuff in there as well? And so we can actually do this with data binding. We can create layout attributes and then kind of hook up custom functions to it. And that's what we did here. And you end up with something like this instead. So, I mean, the attribute name is very long, but it does what you want. And we've used this in various apps over the past 6 months or so, including the IO app. And it makes it much nicer to use, and there isn't one instance of unapply window insets listener anywhere, which is great. Now, if you want to know more about this, that's kind of a whistle-stop tour. I actually wrote a blog post about this, so you can go more into depth and look at the code, called Listeners to Layouts. So yeah, go and read it if you want to know more. Now, Rohan's going to talk more about overriding gestures.
Right. So this is the final thing in the list of 3, overriding system gestures. So Chris kind of talked about it, but what kind of conflicts will apps actually face here? So the left and right edges are taken for back, which means that if you have any sort of horizontally or draggable content on any of those edges, all of a sudden it'll go back instead of the user being able to drag it. So I have an example with photos here where this is a cropping tool, and where previously the user could drag on one of those corner handles, now you suddenly have back there. So this is one good example of conflict. In general, there are a lot of sliders, seek bars. There might be some larger components that there might be conflicts with, which we'll talk about here. But in general, we are adding new APIs, or one new API for overriding system gestures. However, the goal for this new API is to be used sparingly by apps. So namely, it'll give apps an option for overriding parts of each of the gesture zones so that you, as an app, get the touch events instead of the touch events going to the system for back. So in this example, for example, photos can specify 4 rectangles, or 4 of these exclusion zones, where it would get the touch events instead of the system using it for back. One more time, I want to kind of reiterate that there are some restrictions that we did have to work around in this API, because a lot of the feedback we got from users was that back is super important. They didn't realize how to go back in apps like Gmail, for example. Like all of a sudden, it would always pull in the drawer instead of the user being able to navigate the app. So I'll talk through some of that, but in general, back consistency is a staple of Android. It is something we're trying to maintain with the gesture nav mode in the short term. So before I talk about restrictions, let's take a quick look at the API. This is a new method in the view class called setSystemGestureExclusionRects. Kind of a mouthful, but it takes a list of these exclusion rects, and you'll note that it is in the view class, so it is relative to the view coordinate system. Namely, if the view gets translated, moved around in any way, these exclusion rects will come and go and translate along with it. So the way you do this is in your view class, you would, you'd have the list of rectangles somewhere. Maybe you generate it statically, and you just call the method with that list in onLayout. OnLayout does tend to be a less frequently called method in the lifecycle, so there you can also call it in onDraw if you need something to update frame by frame, such as if you do have some sort of animation or who knows. Right, so this is the API. I want to quickly talk about the restrictions now. So back consistency is super important, and we wanted to make sure we maintained that as the gesture nav mode went out. So with this API, an app can only opt out of 200 dips of each edge. The 200 dip number is strangely specific, so I can talk about that a little bit. Namely, we wanted to try to anchor to tappable affordances. So the minimum touch target in Android is 48 dips. We try to think of this as about 4 touch targets is how much an app should opt out at most. So things like view pagers, which we won't really cover here, but view pagers, you shouldn't be opting out. We actually believe that, and have seen in internal testing, that users quickly get used to swiping in the middle of the screen for view pagers, as an example. If an app does opt out of more than 200 dips, what will happen is that the system will basically trim anything above the bottom 200. So it'll prioritize the bottom 200 dips worth of exclusion and trim the rest of it. So in the photos case, let's say that you have these blue rectangles here. So you've got some strange exclusion rects at the bottom, about 50 dips each, and then you've got two large or long exclusion rects that are like, say, 300 to 400 dips. So once those are sent to the system, what we'll do is we'll only consider the 200 dips, the bottommost 200 dips, and we'll trim the exclusion rects appropriately. So what will actually end up is this. This will be the excluded area, and the rest of the edge will take the user back. Now, this is just the normal non-immersive mode. I do want to talk about immersive mode since that is a little bit nuanced here. So the first one I want to talk about is non-sticky immersive mode. And bear with me, my presentation graphic foo is not as good as Chris's, so it'll be a little wacky. But in non-sticky immersive mode, if apps do opt out, they can only opt out of the same 200 dip. And if you opt out more than that, it'll get trimmed down. What happens in non-sticky immersive mode is if a user traditionally swipes in, it brings the bars in first. So the same thing kind of applies here. If you have exclusion rects and the user swipes in from anywhere else on the screen, so top, bottom, or from the edges outside of those exclusion rects, the system bars will first come up, and the user is no longer in the non-sticky immersive mode. So any subsequent swipes will take the user back or take the user home, etc. Right, so this will take the user back, for example. I want to talk about sticky immersive mode, since that is the one exception that we did make here. There are a lot of use cases that we did not want to break, and sticky immersive mode kind of has a weird cutout in the immersive mode series. So with sticky immersive mode, apps do have the option of opting out of the entire edge. So this means that basically if a user swipes on the left or right edges and you've opted the entire thing out, the system bars will not come up. The only way, if an app does opt out the entire edge, the only way for a user to bring in the system bars is by swiping from the top or the bottom of the screen. And once the system bars are there, they are only there for about, I think, a couple seconds, I believe 2 seconds at most. So while they're available, the user can swipe in from the edges to go back. This is the one kind of weird case where basically the exclusion rects get disrespected in this kind of transient state, and the user is able to exit the app. Now, we do only recommend using this sticky immersive mode for single-purpose UIs, flat UIs. The strongest examples here are games or drawing apps, where the goal of the app is to do one thing and keep the user from going back or accidentally leaving. Cool. All right, that's overriding system gestures. Want to jump into some common scenarios with Chris here. So we'll go through a couple here. Scrolling views is the first one that we want to talk about. So with scrolling views, once you set the flags that Chris talked about, the content will start getting drawn behind the navigation bar. So that means that your scroll view should probably pad in its content so that it shows when the user scrolls all the way down to the bottom. So you can kind of see that here where the lightning talk and sessions bubbles are showing above the nav bar instead of being behind it. Right, so the main way to do this is to add that bottom padding. This is all the code that Chris showed earlier. Namely, you use the system window insets, and you set the padding to that, the bottom padding to that. Just a quick note, this is the window insets because this is talking about UI conflict, not gesture conflict. Quick way to remember that. One other thing to note is that if you are doing this with the recycler view, you'll also need to set clip to padding to false. Otherwise, the padding will basically obscure your content as it's scrolling and make it look like you have a nav bar when you didn't really want one. Great. Another strong example that a lot of apps will run into is bottom sheets. Bottom sheets are a pretty popular UI or UX component nowadays, but with the new gesture system, there is the home gesture at the bottom, and we're noticing that users may have some trouble basically trying to drag that bottom sheet up. So you'll notice that if you try dragging it up, you'll start going home. So our recommendation here is to use system gesture insets to increase how much of that sheet actually peaks so that it's easier for the user to actually drag it. This is going to have pretty similar code to all the other stuff you've seen earlier from before, but basically just save the original peak height, grab that early on, and then in your inset on apply Windows insets listener, make sure you increment it by the gesture inset. So the home gesture inset is what you're incrementing it by. Cool. One quick note, users will always be able to go back. Back is not overridable. This is kind of the mandatory system gesture inset that Chris was talking about. So one easy way to make sure that your user can drag the bottom sheet content is to make the draggable parts stick out so they're more attractive tap targets so user learns quicker. You'll notice here that basically you can drag from the bottom and the user kind of sees like the purple and green much more clearly, so they're more likely to drag on that and not make mistakes. Bottom navigation, Chris already spent a lot of time talking about this. This is just kind of reiterating it, but make sure you use the same padding code that Chris talked about, so you get that kind of effect where the content just seamlessly goes below.
Just one thing to say about this one. So the material design components, so bottom navigation, bottom sheet, all those kind of ones. The team is actually adding inbuilt support for this right now. So it hasn't been released yet, but it has been done in most components. So you don't have to do all the code we've just showed you. It's just to show you how you can do it in sort of a custom view or whatever. So yeah, it's just a small point.
Yep. Cool. Want to kind of switch tracks a little bit and talk about something that you might experience that's not related to gesture nav. Well, it is because you set the flags for edge to edge. But once you do set those flags to render behind the system bars, what you'll notice is that in 3-button or 2-button mode, your content suddenly goes behind it on the left and right edges. So if you do have any sort of this like horizontal content, text content, images, etc., you may want to consider padding all of your content in horizontally, your root content in. And in general, make sure while you're kind of developing for edge to edge that you are testing in this orientation. We believe landscape is one of the hardest and only tough cases here to handle. There are a lot of these fringe cases in general, but I think landscape is particularly annoying to check out. But make sure you do get a chance to check that out when you're working with edge to edge. So the code for this, basically very similar to what you've already seen, but with your root view, basically just add the padding using the window insets so that there's no UI conflicts on the left and right edges, regardless of where the nav bar shows up. So this will basically look something like this. One quick note, if you haven't already played with gesture nav on your phone, the gesture nav navigation bar does actually show up at the bottom, the relative bottom of your screen, so this won't be a problem with gesture nav, just with 2 and 3-button modes. Cool.
All right, so navigation draws, which is probably the big thing that app developers ask me about. And so if you watched our presentation at I/O, you probably saw a behavior which no longer exists. So in the next version of Q, which is going out very soon, there's a whole new behavior. So we no longer have the weird swipe the drawer open to first, and then you can go back. We now have it where the user will press on the drawer layout for it to peak, and then swipe out. So this is an update that happened to the drawer layout about 4 weeks ago, in Alpha 02. Now, but that only works with the next version of Q coming out, so we know there's an inconsistency at the moment, and so just bear with us until Q comes out, the next one. But it will suddenly all just work as soon as that happens. But yeah, this is the new behavior. I'll just let it play for a bit so you can have a look. It's not quite a press and not quite a long press. It's more of a press and hold. So yeah, it looks kind of weird, but it does actually work quite well. In fact, one thing to say about navigation draw, actually, just go back a little bit. So the reason why this happened is because we know that obviously there's a lot of apps on the Play Store, and they're not all going to get updated. And so we didn't want to have this inconsistency between apps which aren't updated and then apps which do get updated, and then there's this weird draw behavior which kind of happens. What we've managed to do is by moving the behavior to the system itself in Q, this works with all draw layout implementations. So if your app is out there today using draw layout, it will just work with Q. So that's the whole reason why we've done it. Finally, for carousels, so view pages, as Rohan mentioned earlier, we don't want you to do anything, basically. We don't want you to use the exclusion APIs. You can inset content if you feel that it's really important to not be displayed behind where the user might drag back. But other than that, don't do anything.
Yeah, in general, we had a lot of discussion about this. We saw a lot of fear from app developers that their click-through will go down or users won't know how to swipe it. From some of the testing, some of the beta feedback we've gotten, users take about a couple of days to learn it, and after that, it kind of becomes natural. So just want to reiterate that you shouldn't be acting on any of this. Users are expected to kind of learn this pretty quickly.
So the final thing to say is that there is more support coming. As I mentioned earlier, the material design components team are adding support for all their built-in components, and we are doing the same thing for Android X, like draw layout and the rest. But what we do want to know is if there's any difficult patterns that you have in your apps that you find just aren't applicable or don't work very well with gesture nav, please let us know and we can try and think of guidance or ways around it. So yeah, please let us know. So as a kind of TLDR of the whole presentation, so users will expect your apps to work with gesture nav and also button nav. So please test and update your apps. We want you to create immersive experiences. So you go edge to edge using kind of the whole thing, what we talked about earlier. And as I said, we are going to update MDC and Jetpack libraries and Android X and all the rest of it. And so please update proactively because the support will be in there. Only use the gesture exclusion APIs if you really need them. As Rohan mentioned earlier, we are sort of clamping what the values are. And so they're really more of a kind of backstop rather than this is the way we should do stuff. And finally, please let us know about any sort of scenarios which you're finding hard. So thanks very much. We're going to be around in the booth, in the Google booth outside. If you have any questions that you want to come talk to us about, feel free. Thank you.